right, this is the start of the day 2 notes for circles. This front page, you can find it fully filled in on the website. I'm just going to quick walk you through what you're looking at. So for some review from yesterday's notes, the line across the top, that's a nice tangent line because it just hits at one point. There's multiple chords drawn into the picture. Remember, a chord is any segment whose endpoints are on the edge of the circle itself. So this is a chord down here. These would also count as chords here and here. And then from the center O out to point B or out to point C, those are both considered radii. What's going to be new for today is the angles that are formed. So there's two types of angles in this picture. One, where the vertex is right on the center point, is very nicely called a central angle. The other one, where the vertex is on the edge of the circle and the sides of the angle are two chords, that's called an inscribed angle. So those are the two new terms that this video is going to talk about. The one other detail that I want to mention is that you can have arcs on a circle that are considered minor arcs and considered major arcs. And they sound just like the names would say. Minor arc is something small, major arc is something big. But more specifically, it's a minor arc if it's less than half the circle, so less than 180 degrees. It's considered a major arc if it's more than 180 degrees. So if I slide back up to the picture here, the arc from B to C right here, that's clearly less than half the circle. That would be considered a minor arc. Whereas if I looked at that same arc, but going all the way around the reverse way, so B through A to C, that would be considered a major arc. So to get those full notes, look on the website. You can either copy them down or print them right from the website itself. As for the next page, I'm going to do that part of the notes with you. So on page 2, a couple of quick details that I know you know. First thing is the idea that there's 180, there's 180 degrees in a semicircle, not in a full circle. That should be 360 degrees. So when it says find the number of degrees in the missing arcs, not meant to be super tricky or anything. It's just the idea that if the full circle is 360, and then this piece of it right here is 120 degrees, to get the remaining arc that goes from here all the way around, we would simply subtract from 360. So we can go 360 minus 120, and that'll get us our answer of 240. So this remaining part has to be the other 240 degrees. In this case, notice whenever they give you a point here at the center, we can assume that that is the center point, which means this segment from left to right, that is a diameter. So if this arc right here is 50, the arc that's next to it, those two together are half the circle. And since half the circle or a semicircle is 180, this piece right here is 180 minus 50. So that part of it comes out to be 130 degrees. The bottom piece, that goes from one end of the diameter to the other, that piece of it is just 180 all by itself. So that's this part from here to here. All right, the two angles that we're going to talk about in this particular video are a central angle and then an inscribed angle. So we talked about them on the front page, but there's a rule for it. The center angle, which is on the center point, I'm going to call it angle X. It always comes out to be the exact same measure as the arc angle that it opens up to. So I'm going to call that X as well. So keep in mind, when it's a central angle, the vertex is on the center point. Whereas when it's on an inscribed angle, or sometimes called an on angle, the vertex is on the edge of the circle. And so in this case, it's a slightly different rule. So if I look at it, I'm going to call this X. The arc out here isn't x, it's going to be double what x is. So I'm going to call it 2x. So there's a couple ways you can think of this. For this one, the angle is equal to the arc. So that one's easy. Here, you can think of this as the angle as being half of the arc, or the arc is equal to 2 times the angle. You can kind of say it either way. So the angle is equal to the arc over 2, or I can say that the arc is equal to 2 times the angle. So you get to pick. Right? And now what I mean by that is you'll use it depending on what information is given to you. So we're going to do just a few of these with you. So if we slide down, the very first practice one here, look at where the vertex is. This one's on the center, which means it's a central angle. So that's the first rule. So if this is 40 degrees, easy peasy. This is 40 degrees right there. So arc AC is 40 degrees. The one next to it, where's the vertex? You got it. It's right on the center again. And so if it's on the center, it's a central angle. And so if the arc is 130, then so is that angle right there, 130. Whereas if you flip on over to the next page, you get to see some examples that are a little different. Keep in mind, if I'm going too quick, you can pause the video at any time, rewind, and replay it. Otherwise, on to that next page, when you see that first example for number 3, notice where the vertex is. It's on the edge of the circle. So when the vertex is on the circle, that's called an inscribed angle. So that's what I want you looking for. So the rule that I want to use, I'm trying to solve for the arc. The arc is equal to 2 times whatever the angle is. So if the angle is 25, then this is going to be 2 times 25 or 50 degrees. Number 4, same type of angle because B is on the edge of the circle, but this time you are given the arc out here is 90, and I want to solve for the angle. So the angle is equal to the arc divided by 2. So in this case, if we do 90 and divide it by 2, that angle has to be 45 degrees. Now, some of the rest of the examples that follow can be a little bit tricky, and I like them. So you got to think a little bit, but I'm going to let you try those and then check the notes on the website. If you have questions, of course, just email either me or Mrs. Golding or Mr. Murphy, depending on who your teacher is. I will make a separate short video to cover the last type of angle. So make sure that you watch both so you can complete the full note packet.